in part 13, we need to explore big F double prime. So this is where I'm going to go back to my scratch work from the previous video. Remember where I established the connection from big F to big F prime? And I'm going to think logically how big F double prime would need to come into play. If we just apply basic logic, we can assume that big F double prime must be the derivative of big F prime. So I'm not going to do anything really complicated here. I'm just going to take another derivative in order to get myself to big F double prime. And I'll take the derivative of what I had on the other side of that important statement. That would be little f prime in order to complete it. Now in context, that doesn't seem to mean much. I see that, but at the same time, it doesn't really do anything for me. And if at first you're thinking, well, that's insignificant, I don't know how that fact is going to help me, why is she even bothering to put a highlighted box around that? That doesn't seem important at all. Bear with me here, because again, the key is in the interpretation. Remember, the relationship between big F prime and little f is what allowed me to use little f in order to answer the questions. I didn't need to use big F prime. I could just look at the graph of little f to figure out what I needed to do for parts 9 through 12. So now in part 13, let's again think. It's asking about big F double prime, but we're going to use little f single prime to actually do the heavy lifting for us. So I'm going to, again, just draw a little box around this so you can see where I'm going with this. But hopefully you've already started to think for a moment. How could how could little f prime help us? So when we do question part 13, big F double prime of 2, let's instead think of that as little f single prime of 2. But again, think about the context of a graph. How could you look at little f, the graph, and understand anything about its prime or its derivative? Think about what we know about derivatives. Generally speaking, if we have functions, we can take derivatives of them, but when we have graphs, the word derivative takes on a different meaning. On a graph, a derivative is more often a slope. So this interpretation that I'm going to make here, little f prime of 2, is really asking me for the slope at that x coordinate 2. So let's go to the graph really quickly and let's see, is that something we can actually predict? It certainly seems like it does, because if you look at x coordinate 2, this point here, and picture the tangent line that we would have there, it happens to be that the curve was turning at 2. It looks like I have some sort of relative maximum there or something like that. So the idea that the tangent line would be flat here means that it has a slope of 0. Therefore, little f prime of 2 must be 0. And by extension, that means big F double prime of 2 is 0. So instead of directly answering the question, we basically found a workaround. We still don't know what big F is. We still can't take that integral. And in the terms of area, I mean, double prime doesn't even make sense. So the idea that we can change big F double prime to little f single prime and use the graph to answer the question is very empowering, because that's stuff we know. We know how to look at a graph and find a slope. So this is going to make things way easier for us. Let's try another one. In the next one, part 14, we have big F double prime of 5. And again, let's not think of big F double prime of 5 at all. Instead, let's think of our established fact that this is equivalent to little f single prime of 5. That seems more doable. Little f single prime of 5, that's really just the slope at the x coordinate 5. So we'll look at our graph. Here's 5. The slope is easy to predict because it's a line. So it looks like the slope of that line would be down 2 over 2, or negative 1. So it looks like the slope at that point is negative 1. And again, I don't have to do anything directly with big F because I've established this workaround. Big F itself is somewhat useless, so I'm using little f instead. Now let's just make sure before I finish this video that we make these crucial connections here. If you're talking about little f, you're talking about the graph, little f prime is really just slopes. So now that hopefully you can see these connections starting to form, you can start to get a little bit more nuanced at recognizing what each question wants of you. If you're doing a problem with big F prime, which is the same as little f, it's really just asking for y coordinates. If you're talking about a problem with big F double prime, which is really the same as little f single prime, then it's a question asking you about slopes. So those are basically the two main ideas here, y coordinates and slopes. If you can look at a graph and get y coordinates and slopes, you can get all of these values. Try to finish the last two parts of letter A, and in the next video, we'll start to use what we understand about these relationships, big F prime, big F double prime, and we'll start to overlay some of the function analysis that represents our first semester information.